Knock, knock. Mrs. Kingston. It's me. Did you hear me? It's me. We got to start 4.2. You ready? We should not start class every day like that. Okay, ready? 4.2 objectives. Number 1, change from logarithmic to exponential form. Number 2, change from exponential to logarithmic form. Number 3, evaluate logarithms. Number 4, use basic logarithmic properties. Number 5, graph logarithmic functions. Number 6, find the domain of a logarithmic function. 7, use common logarithms. And 8, use natural logarithms. Okay? So let's remember some stuff about logarithms and exponential form. How about that? Okay? So logarithmic form looks like this. Y equals log base b of x. Exponential form looks like b of y equals x. So notice please that the base of the logarithm is the base of the exponent. Okay? Notice that the exponent in exponential form is what the logarithm equals. And then notice please, this is what's left. Okay, what's inside of the logarithm is what the exponent equals. Got it? So if I say 2 equals log base 5 of x, what is that in exponential form? Well, the base is the base, so 5. The exponent is the answer of the log, squared, equals the argument. What if I wrote it a different way, like freaked you out on purpose? Is that okay? Okay, so what if it said log base m of 2x equals 7? Could you write that in exponential form? Even though I wrote it backwards? Like the log is on the left side instead of the right side? Is that okay? Yeah, because the base is still the base, right? The answer is still the exponent, and the argument is what the exponential function equals. Got it? So what if I ask you to take this and write it in logarithmic form? Can you go backwards? Because that's our second objective today, right? We've been going from logarithmic to exponential. Can you go backwards from exponential to logarithmic? So do it. What do I write? Log base 6 of, correct, equals 2. Got it? So evaluating logarithms is like we already did that. You know what I'm saying? When we talked yesterday about how to evaluate something, you plug in the number for x every time. Boom. Done. Using basic logarithmic properties, let's look at that. Okay? If I say log base 2 of 16 equals x, can you solve this logarithmic for me? So there's two things we could do. Okay, number 1, we could say exponential form, right? We could say 2 to the x power equals 16. We could think about it in our head. 2 to what power equals 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So what does x equal? X equals 4, right? So in this case, x would equal 4. But there is something else we could do. Okay? Because it's equaling x, we could put log base 2 of 16 just straight into our calculator with the log right down here. We'd say control log, log base 2 of 16, and hit enter. Oh look, 4. Just like we thought it would be, right? Okay. What if it was something like this? Log base 7 of 1 over 49 equals x. What would that look like if we wrote it in exponential form? 7 to the x equals 1 over 49. Well, if it was 7 to the x equals 49, you would automatically know that that answer was 2, right? Because 7 squared is 49. So 7 to the second power, 2 sevens is 49. But since it's 1 over 49, you should also know that answer. Because what makes something go to the bottom of a fraction? A negative exponent. So it's just negative 2. But we could even check, right? Log base 7 of 1 over 49. Boom. Negative 2. Log base 25 of 5. 25 to what power equals 5? So thinking mathematically, what action can you take on 25 to get 5? We could either divide it by 5, but if I'm dividing it by 5, I'm dividing it by the answer. So isn't that the same as square rooting it? So 25 to what power would then give me 5? Well, we remember, hopefully, and if not, I'm reminding you right now, okay? If we raise something to the 1/2 power, that's the same as square rooting, isn't it? Okay? But something else, well, no, I don't want to talk about that yet. Okay. What about this one? Log base 2 of 5 root 2. This is what I want to talk about right now. So here's what I want you to remember. There was a property that we used. And since we're talking about basic properties, this is definitely one I want to talk about. Okay? There was a property that we talked about in Algebra 2 where if the base of the logarithm and the base of the exponent were the same, the answer was just the exponent, right? Or what was left. Well, this is almost that way, except this is a fifth root instead of an exponent. Except we know how to write that as an exponent, don't we? We could say log base 2 of 2 to what power? If square root is 1/5, if square root is 1/2, what is fifth root? 1/5, yeah. So it looks like this, right? Aren't these two the same? Well, it's a 5. It's just hard to see. Sorry, I made it messy. Please forgive me. But my point at this point, right, is if my bases are the same, what's the answer? It's the exponent, whatever's left. So x equals 1/5, doesn't it? But for the record, we could say log base 2 of the fifth root of 2. It said 0.2. Oh, that's 1/5, right? Yeah, that's 1/5. There's no reason to worry about that. That's the same thing. Okay? Any questions about that? Ooh. Any questions about that so far? Okay, some other special properties that I want you to remember. Well, that's the one, and it's important, so I'm going to give you another example of it just to make sure you're good. Log base 7 of 7. What does that equal? I'm not even going to put equals x. I just want you to tell me right now what it equals. What's the exponent? Right? The bases are the same, so the answer is the exponent. There's not one written, but we know there's a 1, don't we? Log base 5 of 5. What does that equal? 1. Can I try to trick you? Okay. Log base 5 of 1. So the bases aren't the same, so I can't know automatically that it's a 1, right? So if I think about it in exponential form, it would be 5 to some power that I don't know equals 1, right? 5 to what power equals 1? 0, absolutely, because we know anything to the 0 power is 1, right? So the thing is here's the little basic property that I want you to remember for this. Basic property for this is if the base are the same, the answer is the exponent. In both of these cases, it's a 1, right? In this case, it was a 1/5, right? This property I want you to remember is if the argument is 1, what does it have to equal? 0, because that means anything, no matter what the base is, to the 0 power is 1. That's the only way we can get a 1 here, unless this is also a 1, but then that's a whole nother story, right? Because if they're both 1s, guess what it equals? 1, because the bases are the same, right? Okay? So what about this one? Log base 12 of 1 equals what? What does that equal? 0. Yeah, for sure. Okay? So officially, okay, officially that is called the inverse property of logarithms. Officially, the inverse property of logarithms says for b greater than 0 and also b not equal to 1. It's got to be greater than 0 but not equal to 1. Log base b of b to the x equals what? X. Yeah, for sure. Because the base are the same, the answer is exponent. Okay? The other part is also true. If it's b raised to the power of log base b of x, are the bases the same? Then what's left? X. Does that make sense? Okay, so a sample specifically of this situation, I know we talked about this one a second ago, if these were both the same but there was nothing here, that would be 1, right? But what if it was log base 7 of 7 to the 8th power? What does that equal? Yeah, absolutely, 8. Okay, and what if it said 3 raised to the log base 3 power of 2x? What does that equal? Well, are the bases the same? Yeah, then what's left? 2x. You okay with that? Do you feel comfortable changing from logarithmic to exponential form and then back from exponential to logarithmic form? Do you feel confident in evaluating logs and using basic logarithmic properties? Then let's talk about graphing logarithmic functions. Okay? You already know everything I'm about to say. That's the good news. Because what am I going to talk about if we're talking about graphing? What am I going to talk about? Transformations. That's exactly right. Okay? Transformations is exactly right. So here we go. F of x equals a log base b of j x plus h plus k. Can I fix this? This should be a minus. Please forgive me, that should be a minus. Okay. So tell me what all this does. What's the a do? It is vertical stretch or shrink. Oh, what else could it also do depending on the sign of A? reflection over the x-axis, right? Okay. What about log base b? What does it do? Literally nothing, right? That's what gives it its shape. No matter what this b value is, it could be 4, it could be 17, it could be 3. That's what gives this graph its shape, okay? So what about j? Say it. Correct. And depending on its sign? What about h? And what about k? Yeah. Okay. Now I'm going to write something else under both of these two that's going to seem fairly obvious to some of you, but I want to make sure it's obvious to everyone. Is that fair? Horizontal shift goes which direction? Yeah. It's left or right. I can't tell you how many times I ask about a horizontal shift and people will say horizontal shift up to. Well, guys, horizontal is not up. It's left or right only. Okay? So what am I going to write under vertical shift then? Yeah, up or down. Again, I know that's fairly obvious to everybody, but I want to make sure that it's obvious to everybody. Okay? Now, if we're graphing it, don't we also need to make sure we're confident about the parent function shape? Are you okay with that? Let's make sure that we know what that looks like. Okay? Because it actually leads us right to the next part of the requirements. That's our parent function shape, right? That's what it would be if it was log base 2 of x. Why did I make sure to put this point right here and make sure that my graph went right through that point? So no matter what the base is, because that's just 1, right? There's 1, there's 2, there's 3, and so on. 1 and 2 and 1 and 1, like that, right? Well, log base 2, if x is 1, what does this equal? We just talked about if 1 is in the argument, what does it equal? 0, right? So if x is 1, like I put right here, y is 0. So if x is 1, y is 0. That's why it goes to that point, yes? Okay. So can you use transformations on graphs of logarithmic functions? And do you recognize what the general form or the parent function form is of a logarithmic function? Okay, so then let's find the domain of that logarithmic function. If we're talking specifically about parent function shape, what is the domain of this function? Well, how far left does it go? What exists right here on the axis? I would draw it dotted if you could see it. That's an asymptote, isn't it? Okay, that's an asymptote right there, so it's not ever going to cross that line, is it? So how far to the left does it go? Only to 0, right? Only to 0. It is. X is greater than 0. Not greater than or equal, just greater than. So if we were talking about inequality notation, that's what we write. What if we're talking about interval notation? We would write from 0 to infinity, and both of them would be parentheses, wouldn't they? Correct. Because it won't ever equal 0. This function won't ever get to 0. Okay? So what if I give you a function like this? F of x equals log base 2 of x plus 4. What's the domain of that function? Well, tell me, transformation-wise, where does this go? It goes to the left 4. Well, if this is shifted to the left 4, what's the new domain? Yeah, x is greater than negative 4, right? Because it shifted to the left 4 because it's going to be negative 4 over here. But it's everything greater than that. Okay? Or from negative 4 to infinity, right? What if it said f of x equals log base 2 of x plus 5? Do you notice something different about the second equation than the first equation? It's not in parentheses, so what does that mean? It is a vertical shift, okay? Whatever's in the parentheses, that's going up or left or right. If it's not in the parentheses, that goes up or down. So if all it's doing is moving up 5, tell me about the domain. It does. It stays the same as a parent, right? So it's just x is greater than 0 or from 0 to infinity. Any questions about that? Okay, so our last two objectives of the day are using common logarithms and using natural logarithms. Okay, common logs and natural logs. Do you remember the difference between the two? Is it okay if I remind you? Okay. So if I tell you, like all the stuff we were talking about before, all this stuff, putting it from exponential to logarithmic and stuff like that, if I said log of 5 equals x, what would you notice immediately? There's no base, right? Well, because we're talking about common log, what base is actually there? That's a base of 10. Okay, so common log is a base of 10. So if I ask you to rewrite this into exponential form, what would you write? 10 to the x power equals 5. And we could go solve that later on if we wanted to, right? We don't want to right now. Because this is something we could just put directly in the calculator, right? Log base 10 of 5 to solve for x. Okay. So what is common log? It's log base 10. We just don't write that because that would be so juvenile. We just write log. Okay? So if it's just log, you know automatically it's like an understood 10. Okay? So the other thing we have to talk about is natural logs. You remember natural logs? So if I was writing something like this but using a natural log, it would look like this. Okay, so first of all, natural log does not start with a L. So maybe this was French and it was like log en naturel. Or probably not, I just made that up. Okay. LN, right? No, I didn't make up LN. LN's a thing, right? I just made up the French part. Okay? But what does this mean? Well, that means log base E. But just the same way that we don't write log, well, we can write log base 10. We do not write log base E because that would be ridiculous. Like other mathematicians that came up here, they would look down their nose at us. Like, what kind of ridiculous people are you writing log base E? Okay. Now, log base E actually lives on your calculator right there, ln. Well, you're about to touch that now. Okay. Control that button to get natural log. Also, here is where you get the E as well. Okay, there's actually two places to find it on your calculator, but if you use this one right here, it's E already to the X, so it's E already raised to a power for you. If you don't want that, go down here to the pi button, and if you press the pi button, see that E right there? that's what shows up and you can go and get that e. It's just not raised to a power. You would have to like raise it to a power yourself, because that's so difficult if you need to do that. Please, please, please do not use this e. Don't. It's the wrong e. Okay? This e is specifically stored as 2.818272, 2.71828, or something like that. I don't have to remember it. Why? Oh yeah, because it's right here. We could even figure it out. Watch. If I just press enter, it'll tell me. 2.71828. That's what E stands for. Okay? Guys, I know your whole life people have been telling you that E is a letter. That's because it is. But we in math, especially Algebra 2 level and up, we use this E to represent the number 2.71828. Okay? It's a big deal in higher level math. It's one of those numbers that show up everywhere, just like naturally. Like pi shows up with circles, right? E shows up naturally. Well, I want to say in nature, but it seems like I already said that because I said naturally. You know what I'm saying? If you'll give me a second after we finish the lesson, I'll show you some examples from the computer so you can see them. And I'm not talking about math examples. I'm talking about like nature examples, if that's okay. Okay? So I need you to make sure you understand that things like this, natural log of e to the fourth power, you should be able to tell me the answer of that super quick because of the fact that this is log base e to the fourth power. And what do you notice about these two things right here? The base is the same, so what's the answer? Yeah, 4. Okay? So natural log of e to the 2x, what should that equal? 2x. Okay? Or even this, e to the natural log of 4x, what should that equal? That should equal 4x, right? Because the base and the base are the same. So the answer is what's left. The answer is in that exponent. Does that make sense? How comfortable are you with our objectives for today? You ready to go? Ready to rock and roll even. Awesome.